Hi, everyone. Thomas Howard. I'm one of the technical marketing engineers for ICE, and I'm glad to kick off 2022 with this new webinar series that we're doing called the ICE Basics. The idea here is we presented some fairly advanced topics for you last year, and this year we want to try and get back to basics and hopefully help some of our newer customers and those that are trying to configure some features and capabilities that may be new to them. So we're going to go ahead and try and do this basic series. And you saw some of the topics that Rigo has lined up for us in the next couple of months. And so the other thing is, this is a beginner type session designed to give you an overview of ICE for the Zero Trust Workplace. And so hopefully you'll be able to walk away with a better understanding of what ICE does and how it can help you with zero trust and doing secure access in the workplace. So with that, these are the different topics we're going to touch on today. Basically, trying to give you a background, what does ICE do? How does it fit in with your security strategy? For those of you that aren't necessarily familiar with AAA or Radius and TACACS protocols, give you a quick overview on those, and then get into how ICE helps you secure your network and help with zero trust. And go over some of the protocols we use to do that, such as 802.1x and MAC Authentication Bypass, how we help you get visibility about the devices coming into your network so that you can then perform some enforcement, segmentation, and finally, some of the integrations that you can do so that once you do allow devices in, if they are infected or they have any problems, you're able to rapidly contain them and limit the blast radius of any kind of a attack or infection. So with that, I want to get started with kind of how we got to where we are today with zero trust. So it started out, I think we all have experience, going to the office, connecting our computer and just getting access to the apps and things within our company. And then over the past few years, we've really seen an explosion in the Internet of Things. So a lot more devices have to be connected and secured. And then, of course, we began to have a lot more people working from home, getting mobile devices, phones, tablets, all these different things. And of course, with the pandemic, that definitely exacerbated it. So almost everybody was working from home for at least a period of time and may still be now. And then, of course, you can't deny, apps moving to the cloud and doing software as a service has become a huge motivation for a lot of companies to try and save money and simplify things. But all of this ultimately has meant that it's a lot more for us as networking professionals to try and understand what's the perimeter, who is it, what is it out there, what are they connecting to, how do we secure it, things like that. And ultimately what this is presenting for us is the opportunity, unfortunately, for things to sneak in to our network, whether it's people at home not patching their stuff or them bringing it inside of our corporate network, or even people that configure certain services, they leave it wide open. And we've heard, I think we've all heard of the different attacks in the news where people just didn't bother to secure their database in the cloud, and people are able to get access to that information. So ultimately, this comes down to having excessive trust and not minimizing it. So if something bad does happen, you can minimize that attack surface. So what we want to try and do is move from this excessive trust to starting to lock things down more and have what we call zero trust. And so this means that you basically want to authenticate everything coming in. And the way we do this is making sure that, first of all, we know who our users are and what devices they are using. So we authenticate them so that we know that they're our devices and our users. And then when they do come into the workplace, we obviously want to do the same thing, but then we want to enforce access control capabilities so that we limit what they are able to access to only what their role is allowed to do on our network. And then, of course, if we have applications that are out on the cloud outside of our corporate network, we want to secure those workloads. And Cisco has many different products to help you do all of these things for the workforce, the workplace, and the workloads. And with ICE, we're really focused on the workplace, right? When you come in, or actually even with VPN, when you VPN into the corporate network, we will authenticate you. And what we want to try and do, obviously, like I said, is get visibility of your devices and your users, apply access control policies to perform segmentation and limit what they can access to what is necessary for their role, and minimize any chance of excessive trust. And then, of course, once they do come in, if there is any bad behavior, whether it's malicious or maybe it was unintended on the user's part, they didn't know they had a virus, but the machine is, working in the background to try and extract information from the company and exfiltrate data or something. We want to make sure that we can quickly detect those with other security services who can then contact ICE and quickly contain that problem. So these are the kinds of ways that ICE can help you with zero trust in your workplace. And so the way this typically works is we have ICE and we can deploy it, in our own data center or multiple data centers around the world. You can even deploy it now in the cloud and AWS, and we've had lots of webinars recently on how you can do that. So when you want to secure users and devices coming into your enterprise network, basically you have these network devices, your wired, wireless VPN devices, and they are going to implement access control technologies, which we'll talk about, so that and those are configured, by the way, by Cisco's DNA Center, so you can provision them to know that ICE is the AAA server that they want to authenticate the users and devices against. And it will also tell ICE that these are all of your network devices that you will be receiving access control requests from. So that when these users and devices come into our network, we're going to be able to authenticate them against our backend database of identity services, whether that's Active Directory locally, maybe you're using Azure AD in the cloud, or you have a SAML service or ODBC service, something like that. We have the ability to authenticate those against this authoritative database of users and groups. And then once we determine that we're going to let those users and devices in, like I said, we can share that information out with other security services, whether it's a group-based firewall, whether it's something like an analytics service to track all your flows to see what people are doing on the network, or maybe it's a vulnerability service that we want to let them know that, hey, we have a new user, go kick off a scan and make sure they don't have any known vulnerabilities. So we'll be talking about these things later on, but this is just meant to give you kind of that idea of what ICE is helping you to do in your enterprise and the security side of things, because we typically have a good mix of people using ICE. Some of them are on the enterprise networking side, some of them are on the security side. So we want to really show you how we can tie both of those things together with ICE. All right, so hopefully you can see now that with the erosion of the traditional perimeter, identity is now your foundation of security. And that is why access control based on identity is so important. And so the thing that we try to do is obtain or retrieve what we call context from the users or devices coming in. So you've probably seen, who, what, where, when, why, how. You've seen this before. This is very common in investigative journalism, as well as, some of you may have played the board game Clue. And the idea is you want to find out who did something in a particular place at a particular time. Maybe you know their motivation, maybe you don't. But ultimately, you need to get down to the bottom and kind of figure out that mystery. And that's what we're trying to do with access control, is it tracks all of these things. So first, we want to know these things so we can make a good decision to, like I said, limit or avoid any kind of excessive trust and only give permissions based on their role or profile or what level of compliance they are in terms of their software and patches and things like that. And you may have different policies based on where they're coming from or what time of day they're coming in. And ultimately, you have this policy because you need to know why should this user or this particular device have access, and why should they have what kind. You just think of those as your different scenarios for different users and devices coming in. And ultimately, how are you going to implement that access? Are you going to use VLANs or ACLs or software-defined segmentation, which we'll talk about later? So we put all this together in what we call AAA, or authentication, authorization, and accounting. So the idea here, just to use some basic definitions, is when you authenticate a user or a device, you're basically verifying their identity. And this is typically done using different factors. There's typically three. You don't have to use them all, but you've probably heard of this concept of multi-factor authentication, and that's where this came from, is you can use one or more factors to authenticate the identity of an entity. And one is knowledge, so what you know, which is typically a password, right? Or it could be something that you possess, which is something like a token. And then finally, something of your being, which is, biometric data, whether it's a retinal scan or a fingerprint or something else. Those are the ways that we can authenticate the identity of a user. Then you have authorization. So once we know who we're dealing with, we can check on what group membership or role they have, and we can grant rights or permissions to the network based on those things, right? And that's how you limit that excessive trust, is you only give them what they need. They usually don't need access to everything. It's awfully convenient to just give them everything, but that's typically not a good idea. So you have to figure out how you're going to limit things. And then finally, once we authorize them to the network and we let them start sending packets, we want to make sure that we recorded their access, because if we ever have to go back in time and understand how did this happen, who accessed the network, why were they given these privileges, were the privileges too loose, too excessive, we want an accounting of that, right? And so that's how AAA ties all these things together with security to help you with your zero trust. So one of the first protocols ever implemented to do zero trust, to do AAA, is TACACS, the Terminal Access Controller Access Control System. And ISE is a TACACS server. So this is used when you want to authenticate and authorize your network administrators, or in this case, you can see even your help desk administrator, your support staff, to be able to log into different network devices and issue command line queries or configurations on your network devices. So this is specifically about configuring your network devices. And we're not going to go into this today. We're going to talk specifically more about access control for the network with Radius. But just know that ISE does support TACACS, and this is a way of helping to protect your network and make sure that not all users can do everything on your devices. You probably don't want the support staff configuring your routers and switches. They can take a look at it and see what users are on or what devices are on it, but you don't want them configuring it, right? So you have these different roles and things for doing that, and that's what TACACS does. But for network authentication, we use a protocol called Radius, the Remote Authentication Dial-In User Service. And this goes way back to the 1990s, right? This protocol is probably older than some of you on this call today. So we have the RFCs up there that talk about Radius if you want to see all the different capabilities and how it's evolved over the years. But the idea is you have an endpoint that wants to come in, and you could be doing a layer 2 802.1x connection, or you could be on VPN. And then we're going to do a Radius authentication based on those user credentials to our AAA server. And then it is going to consult an identity store to see if those credentials match, obtain the group, and then authorize that user to the network. So in reality, it looks a little bit more like this, right? We've got all these different clients coming in and connecting. Some may or may not be configured for 802.1x and stuff, but they're going to connect and they'll do 802.1x, or maybe they'll do VPN tunneling into our network devices. Those devices are going to send a Radius request into ISE, and then ISE can consult one of many different types of backend identity stores for doing the authentication of those users and devices using passwords, certs, even multi-factor authentication if that's something that you need, right? So this is the quick overview of how Radius works. And now what I want to do is start to talk about 802.1x, so you understand how that works when you associate to a wireless controller or authenticate to a switch. So the way it works here is you have a user with a computer, and it has what's called a supplicant. And that's just basically just a fancy term for a client. And what happens is when you connect, you plug in you get a link up on that switch, and it's going to trigger what's called an EAP start. An EAP is the Extensible Authentication Protocol. You've probably heard of a lot of different EAP protocols, such as PEEP, TEEP, EAP TLS, right? All these different EAP-based protocols are all designed to build a tunnel so you can securely transfer your credentials. And so in this case, once we get that link up, something like a Windows machine can prompt you for your username and password. You can put those in, and those are going to get bundled up as your credentials into an EAP frame in 802.1x. That gets sent across. And remember, the way .1x works is you don't even have an IP address typically. The idea is if you're not authenticated, you don't get network access. So we're doing this at layer 2 in 802.1x. We send it to the network device. It's going to repackage it from layer 2 into layer 3 in a radius packet. And you can see that there's a whole bunch of different, what they call AVPs, or attribute value pairs, that Radius uses to communicate this request for network access. So we're going to send this over to ISE, and we're going to give it all these attributes so it knows what kind of request. Is this what's the MAC address of the user? What MAC address is it connecting to? What is the location? What is the connection type? Is it wired, wireless, VPN? All these different things. And when it goes over to ISE, ISE can now take that request with those credentials and run it against its policy and decide, okay, based on the access that's being requested, let's authenticate the user. So let's take those credentials and let's send it over to our identity store and authenticate it. Let's see if it's a valid user. And yeah, if it is, we're going to get the group membership information, or the role of that user or that device. And we're going to take that, we're going to evaluate it against our access control policies to only give it the right amount of access to our network. We're going to then take the enforcement of that session, and we're going to put that into a bunch of attribute value pairs and Radius to communicate to the network device how we want that session secured. Are we going to apply a VLAN? Are we going to apply an access control list? Are we going to redirect them to a website or a portal? Are we going to apply a scalable group tag? And we send that over to the network device. It then takes those Radius attributes and applies them to that session, and it can then let the user know, congratulations, welcome to the network, get your IP address and start surfing the web, right? Or if for some reason it doesn't work, we can also fail the user authentication. So that's basically how 802.1x works. One other thing to note is we also have something called MAC Authentication Bypass if a device doesn't support .1x. So, we just went through the easy scenario where things just magically work. What happens when they don't? Because the device does not or cannot do 802.1x. And by the way, the reality that I've seen isn't that the devices can't do .1x. Cameras, printers, phones, they've been able to do .1x for like a decade. The real issue is people don't take the time to configure it. And because it's probably not your job to configure all the cameras and the printers and the phones, it's somebody else's job, and security probably isn't important to them. So these things don't get configured, and that's why they can't do .1x. But we have to deal with this anyway. So what are we going to do about it? Well, what happens is if we try to do MAC Authentication Bypass, what happens is we link up on that device, and we're going to challenge that endpoint with that EAP protocol, but it's not configured to .1x, so it's going to just time out, right? And it's not going to respond. And so what we then need to do is go, well, we know we got a live endpoint out here that wants to get authenticated. And meantime, it's probably been ARPing and stuff. And so the switch knows the MAC address. So what it can do is once it times out, it can turn around and talk to ISE and say, hey, ISE, I've got this MAC address and it's trying to connect to me on this port. And what should I do with it, right? So ISE can look up and say, do I know this? Have I seen this MAC address? Have I associated it with a group or a role? And if so, it can turn around. And by the way, there's there's different types of radius services, and the one for MAB is called a call check. The MAC authentication bypass isn't actually a standard, but most companies that implement it, they typically do it with a radius service type of call check, but it can vary between different vendors. So ISE is going to, if it knows it, it can go ahead and accept it. Or sometimes what you'll see happen is maybe guests come in and you don't know their MAC address, right? It could even be a private MAC address and a randomized MAC address. And so you may want to just go ahead and accept them anyway because it's just a guest connection. So you'll give them some minimal amount and then you're going to redirect them to a web portal for authentication, right? So sometimes that's a perfectly acceptable way to use MAB as well. So it just depends on the purpose, but know that that option exists. So with that, hopefully I gave you a quick overview of how this process works. So I want to try and make it a little bit more concrete for you and show it to you in ISE by showing you some of these different things. So let's flip over and let's take a look here. I'm going to go in and I first want to show you that we have some network devices configured here. Okay, and I'm actually going to be using this wireless LAN controller. And what you'll want to notice here is when I talked about the ability to know the type of authentication, where something's coming in from, you can see we have a location field that we can configure. This is typically done in ISE using something called the network device group. And we have these different groups that you can use. One can say that it's a wireless device. You can have it associated to a location. Some customers, you know, if you're like a university, maybe you want to associate it with a particular department. If you are a large company spread around the world, maybe you have different organizations, maybe you have different sub companies or you know, different ways that you organize yourself. And depending upon where it's coming from in your organization, you may want to handle the policy differently. And this is how you can do it using these network device groups. You can create your own custom ones as well. So that's how we can figure out the where. The next thing we want to look at is our policies. So we have this idea of policy sets. Policy sets are used because they really help you scale and manage your different access control policies. So real quick, we have different sets. And so inside of each of these, so we have different sets here. Inside of each of these, we have different authorization rules based on these different conditions over here. So depending upon, like if this one, if it's a MAC authentication bypass, we assume that it's going to be used for guest access. And so we'll go handle our guest authentications and authorizations inside of this policy set. For employees, they should be using 802.1x to authenticate. So we'll be using that policy set for that. Or if somebody's coming in from VPN, we have a different policy set for that, right? So that's how all these different policy sets are used with these different conditions. And you can actually see these different attributes. The radius NAS port type, that will actually, in this case, it says virtual. That means, you know, virtual private network. That's one way to tell the network access type versus something that may be wired or wireless. And then, of course, you can see we also have the device type that it's connecting to. If it happens to be a VPN device, then we'll go ahead and we'll handle it. So that's the policy sets. I'm going to go ahead and drill down into this employee one because that's the one we're going to be using. The first thing you'll see is authentication policies. We basically have a really simple policy here for all employees. They basically are going to go in and they're going to authenticate against our Active Directory, and dcloud is Cisco's demo cloud, so that's the one that's what I'm using for the demo here. It's going to connect into dcloud, and once we get authenticated, assuming we get authenticated against Active Directory, we have a whole bunch of different policies here. So based on the SSID, if it's wireless, which one we're coming into, and we're going to check and see if we're an admin in the Active Directory group. Maybe we're a member of the Tier 1 Active Directory group, and we're hitting a different SSID. Maybe we're doing wired, and we're a member of these groups. And so we have all these different things we can check for in terms of, you know, where they're coming in from, what service, what, you know, SSID or service set identifier they're trying to connect to. In this case, you can actually see we've tied some mobile device management rules to it, making sure it's registered and compliant. And based on all these different rules, we can determine whether or not we allow access and how much access, or if we have to, maybe we need to redirect them, right, to update their software or check in with the MDM server. So we have these different policies that we can write for that. So the other thing we can do is once we've run them through these policies, we can go to our live logs and we can actually look at our live authentication. So what I'm going to do here is I'm going to turn on my iPad and I'm going to perform a quick authentication for you all. All right, it should have authenticated. Let's see if I refresh it. There we are. Okay, perfect. So what we see here is I authenticated as an employee. So you can see who. This is a form of the what with the MAC address. The endpoint profile hasn't come through yet. I haven't actually gone to a website. Let me go to a website and hopefully it'll be able to determine that I'm an iPad. Then what we do is we can see the authentication policy that I hit. So I had employee access. You saw that that authentication policy set and which rule we matched against. You can see what permissions were granted in the authorization profile. So we gave them standard user access, right? So we're able to do all these things. This one is actually showing that we created a radius session. And notice that we have yet another one saying, yeah, the authentication passed. But what this one was, is this was actually a downloadable access control list. So we downloaded an access control list for our user access, right? So what you're able to do here is you can define your ACL inside of ISE, and then if the network device doesn't have it, it can request ISE to give it to it for that assignment. So if we say, hey, use this ACL, and it goes, I have not seen that ACL, ISE, give it to me, please. ISE can download that access control list to them and have it applied, and then it caches it for all subsequent users that get that same ACL. The next thing we want to do is I want to go show you some of the reports. So if we go to operations and reports, so we've been talking about the ability to do authentications and radius accounting, things like that. So the first thing is radius authentications, right? You can see this is our basically where we have a record of all of our authentications. So you can see that the employee came in and it does happen to show the ACL download that happened as well. And if we go over to radius accounting, right, you can see we had the employee had a previous session. It was stopped. They ended that session. And then we had an interim update. So this is something that happens once you start a session. It kind of keeps updating, and then it can eventually end. And then we can see we started our session here. This is UTC time, so it's a little bit it doesn't quite match up with my time zone. But the main thing is it's UTC, and you can do the calculation for your particular time zone. But you can see we have the start of a session for this employee at this MAC address. And this is establishing your accounting information for this particular session, right? And the last thing I wanted to show you is context visibility. So what context visibility does, it basically keeps track of all of your individual endpoints and users coming into your network. And so you can see here, we have our employee at this IP address coming in from this location. It didn't update the iPad profile, hasn't detected that yet, so that's why it's still coming up as unknown. But then you can see the authentication policy that we matched, and you can see the profile that was applied. So if anybody ever wants to know what type of access did we give this particular employee at this particular day, you can see it was the tier 2 wireless, and we can go back in and we can look and see what specifically was assigned in terms of ACLs, and you guys saw the ACL that got downloaded. So we can track all of that if we want to go back and troubleshoot or understand what kind of access did we give them. Was it too much? If so, what was it? So that's kind of a quick demo of how ISE performs authentication, authorization, and accounting, and how you get that information, how we collect it all together for you so you can get that context. I want to flip back now to our presentation, and we'll take a look at some other things. So the one thing, since we've gone through all this, I want to talk about ISE compatibility. This is a really important topic because we get a lot of people that are confused about what ISE can support. I want to stress that ISE is a AAA server that supports Radius and TACACS protocols, right? If somebody says, does ISE support my network device? The first question I say is, does it do Radius? And if they say yes, yes, ISE supports it. So please remember, ISE supports Radius and TACACS. If your device can do it, we can support it. The only devices it won't support are the ones that are, usually clearly identified as unmanaged. The unmanaged devices, they don't have that capability. That's why they're called unmanaged. But otherwise, almost every networking device, from a major networking brand is going to support Radius and TACACS. I think really what people are asking for when they ask that question, does ISE support my network device? What they're really asking is, can my network device do all the cool stuff that I want it to do with ISE? And for that, you can consult our Network Device Capabilities Guide. And there we try to outline, when we last validated these things, this is what was supported or not supported, or if it had some particular issue and limited support for a particular feature. And then we go through and we try to identify, at least with, Cisco's major platforms, we try to let you know, have we tested this device? And if so, what was the minimum OS and what was the latest validated OS that we tried this with, right? People still say, oh, I don't see my device on this list. Will it work? I go back to, does it support Radius, right? If it supports Radius, it will work. So it's just a matter of what capabilities does it have in the hardware and in the software to do all of these things. So something like TrustSec on the far right column, some of these devices, they don't have the hardware capabilities to do TrustSec, so that's not there. Other things may be missing something, probably URL redirection, if I had to guess. That's why guest isn't working on this. They don't have the ability to do ACLs and URL redirection, so those capabilities are going to be limited, right? So it just depends on the hardware and the software. So keep those things in mind when you go to implement it. So I talked about identifying your users and devices. And obviously, if you can authenticate them, then you have a very clear indication of who or what they are based on their group or role, right? But sometimes you can't always know who's connecting. Sometimes you want to do profiling. And this is where, I have my phones and my printers and cameras. They don't have a user, number one, so they can't type in a password. And maybe they haven't been provisioned with certificates or some other authentication method. And so I need some other way of knowing that this is a phone or a camera, and I should put it in a particular VLAN or scalable group, something like that. So what we do is we use profiling to use these different probes. We have these different ways of detecting network information from these different endpoints. We collect these attributes and information, we run them through a policy, and we are then able to determine, based on the DHCP attributes and the HTTP headers and things like that, what kind of device this is. And once we know that in general, okay, this is a camera, we can lock it down into a surveillance group. Or if it's a phone, we put it on the voice VLAN, something like that. Now, to do that, ISE has about over 500 built-in endpoint profiles, and we also have a feed service to continually update those. But we also have some packages that you can download for medical devices and some different building, IoT, and automation devices so that you can use those in your workplace. So obviously, if you're a medical healthcare center, you want those. If you're not, you don't care about medical devices, right? So don't download those and put them in ISE and spend any extra time processing those. But if you do want to, take a look at your thermostats and your lighting systems and your HVAC systems, you probably want the building and automation package. Alternatively, we have some integrations with the Cisco Industrial Network Director and more recently Cisco CyberVision, so that these applications use very specialized protocols to detect PLCs and different things on manufacturing floors and understand what they are, and then they communicate what that device is to ICE, so that when ICE sees the MAC address, it goes, "Oh yeah, that's right. IND told me that this MAC address was actually, a robot on the manufacturing floor, and I need those to assign this particular policy to it." Another way you can do it is something more recent, which we call Cisco AI Endpoint Analytics. And what this does is it actually uses deep packet inspection to look more closely at a lot more protocols than what ICE does by default, and sends those up to the cloud, processes it with machine learning, and across many different customers, it's able to make recommendations about what we think this particular device is to you, so that ICE can then classify it and assign a particular role. So that's another interesting way of doing things. So depending upon what technology may work for you, or what your particular environment or vertical is, there's some different options for you here. So the other thing that we can do is we may know who you are by authentication. We may profile you to know what the device is, but sometimes it's not enough just to know, based on DHCP attributes, HTTP headers. We need to know more. We need to get inside of a device and really find out, what operating system are you running? What patch level are you at? Do you have certain security policies enabled, like pin locks and other things? So for that, we like to rely on what we call posture and compliance. And this is typically something that you do for a bring your own device scenario. So if you have your employees that want to use their own personal devices, you still want to make sure that they're being secure, so that when you do let them in and you let them have a certain amount of access to your network, that they're not using a jailbroken device that's been hacked, that's been going to be used to spread malware or something. So you want to make sure that there's a minimum amount of security in place, right? So you typically do, it can't be jailbroken. You do a pin lock. Maybe you have a secure container. So if they do capabilities with AnyConnect or with our agentless option, these are the different kinds of information that you can gather on the different operating systems. And if you wanted to actually make sure they're patched and updated, and check for things like USB devices, this is your kind of summary of all the different possibilities based on that capability. So I did mention AnyConnect. VPN is obviously what AnyConnect does, but it does have a module that you can add in for your employees' computers called a Network Access Manager, or NAM. This is an alternative 802.1x supplicant if you want to use that. One of the things that it offers that something like a native Windows supplicant won't do is if you want to do MACsec layer 2 encryption, if your hardware doesn't support it and you want to make that a requirement, Network Access Manager can actually implement that in software for you. And it does have the posture module. So if you wanted to do the posture, you can push that out with AnyConnect, and that's how we can collect the posture information. And it clearly does a lot of other things as well. So depending upon what you want to do with AnyConnect, it has all these different modules. It makes it really, really useful to secure your endpoints. So what we want to talk about now is, now that we kind of got an inventory of who and what, and we've been able to take a look deeper inside of these different devices, let's talk about the actual minimizing access and the excessive trust. Really what we're talking about here is the principle of least privileged access, right? So we only want to allow the necessary amount of access, or the network access permissions, for these users and devices to perform their role or function, right? So that's the principle of least privilege access. And we have a couple of different ways of doing this in ISE. The first is something that I think, when you think segmentation, VLAN probably is the first thing that comes up in the network world, right? This is like the Swiss Army knife of security, is using a VLAN for everything. So we can dynamically assign a VLAN. Like I said, when 802.1x authenticates you, originally back in the day, you didn't have an IP address. Since then, we've maybe assigned a default VLAN, and the device was able to get an IP address. But then once we authenticated it or we profiled it, understood what it was, then we change the VLAN. We dynamically assign the VLAN based on that new information. You can do that, but this has problems. The first is if you dynamically change a VLAN out from under a printer or some other camera, some other device, you change the VLAN, but the device may not know that it's on a different VLAN, so it may not do read DHCP and get a new address for the new VLAN, which has a new subnet attached to it, right? So that can cause problems and cause orphaned devices with old IP addresses on new VLANs. So for that reason, dynamic VLAN assignment isn't something we recommend unless it's a pure layer 2 assignment, meaning that if you do not use a default VLAN, just have no VLAN and then assign the VLAN dynamically, that will be fine. But if you try and change it, have a default VLAN and then change it to some other one, you can get orphaned devices. We do have other ways around that by detecting, oh, this is a printer. I'm actually going to do a change of authorization and I'm going to take the port down. So there's a link down and then a link up. So that's a physical communication to the device that it lost link and it needs to do a read DHCP. So we can play those kinds of games if we need to, but in general, just be aware that that can cause problems. So you have to be careful about how you do dynamic VLAN. For that reason, we really, really, really like using ACLs. You can assign a default VLAN, and once you get more information, rather than changing a VLAN, you can just assign a different ACL, and that will block traffic at an IP level. There's different kinds of ACLs. First is a downloadable ACL. Then there's named ACLs, which typically you pre-configure on your network devices, and then ISE just sends it the ACL name. It matches the name and goes, okay, that's the name of the ACL I apply. Thank you, and it does it. As opposed to a downloadable ACL, which you saw earlier in my demo, where the wireless controller, we gave it a name, it didn't have it, so it requested it from ISE, and ISE then provisioned it dynamically. That's nice because it allows you to centrally provision your ACLs instead of having to make sure that if you want to apply a different ACL, you got to go, do a network update and update all your network devices to have that new named ACL. This is a little bit more dynamic. Finally, we also have a DNS ACL. This is something fairly new in the wired world, but we've had this capability for over a decade on the wireless side. Back when we originally started doing BYOD, we needed a way to limit access and redirect to the Google Play Store and iTunes and all this kind of stuff. And so we had to implement DNS ACLs in wireless. But just recently, I believe it's in iOS XE 16.9 or so, they implemented DNS ACLs for switches. So that's a really cool thing if you want to be able to do that. The reason why ACLs are nice is it's layer 3, and so you are able to have unique ACLs for every IP address on a switch port. So if you have multiple endpoints on a single switch port, you can now apply an ACL that's unique per IP address on that port. Whereas if you did dynamic VLAN assignment, not that this would happen, but if you had a printer, a camera, and a user all on the same port behind a hub or something, right? How are you going to put them all on the same VLAN if you wanted to have a unique VLAN for each of those, right? That doesn't work. Either the last person in wins or the first person wins and the last two just get to ride for free on that same VLAN, right? That doesn't work. So having the flexibility to be more specific with your ACLs is a really nice option. Finally, we have scalable group tags. This is where you do what was called TrustSec or Cisco's group-based policy with software-defined access. This is something that we implement at the hardware level, and in every frame, we tag the frame with a numbered group, a 16-bit SGT assignment. This is something you're able to use so that as this frame travels around the network, you are able to apply policy against it. And now instead of having to worry about this is coming from a particular source IP address, and having to know every single possible source IP address and every destination address and have a massive ACL for all those things, you can now do group tags and say, this is an employee, it's going to a particular application in my data center. Is that allowed or not? And if so, on what ports? Done. Really simple. And that gives you much more intent and context for your policies. It's easier to read. We often call this with a firewall, right? It's a group-based policy for your firewall. Incredibly simple compared to the old days of having to update millions of lines of access control entries for all these different IP addresses that you may or may not even remember what they're for. So that's where scalable group tags are really, really helpful. So the way this works is, like I said, typically everybody wants to do VLANs for everything. The problem is that it's not just a VLAN, right? You now got to have a subnet with different unique addresses. You got to have DHCP scopes. You've got to have routing for all these things and applying policy for all those different unique subnets everywhere, and all your different offices around the world can get pretty crazy. Wouldn't it be a lot easier if we could just do scalable group tags? We have a generic data VLAN. We don't care what the VLAN is. Make it unique. It's just a broadcast domain, right? Voice is separate, so we'll do a special voice VLAN, right? Otherwise, all those data packets, if they try and send data out based on their assigned role, they may or may not be able to reach their destination based on the group policy. So that's why group-based policy can greatly simplify your segmentation. The way we do this inside of ISE is using what we call the TrustSec policy matrix. So what you can see is on the left side over here, we have our source tags, and over here we have the destination tags. So they're basically, you can see cameras and cameras, contractors, and so things in the camera network can talk to other things in the camera network, right? That's fine. But cameras shouldn't be talking to contractors, so we're just going to outright deny that, right? And then here's an interesting one. What if we have contractors talking to contractors? What about that one? Or employees talking to contractors, employees talking to employees? Should we allow that? Well, isn't that one of the major ways that malware spreads is by coming in from one person's computer and then spreading to other computers? Wouldn't it be nice if you could have an ACL that magically blocks all that? Well, you can. So what we can do is apply a security group ACL that says, you know what? When these computers, my employees and contractors come in, they shouldn't be DNS servers. They shouldn't be doing SNMP. They shouldn't be using Telnet anymore, right? That's insecure. They shouldn't be doing all these different protocols. And what they really shouldn't be doing is talking to each other on port 445 at the SMB protocol, right? Because we all know how many malware issues have been caused by SMB. And so maybe you allow SMB to a file share server somewhere else in the network, but not from one employee to another, because that's how you get malware spreading. So you're able to do this, and notice that it's agnostic. We don't have to put IPv4 or IPv6 addresses in there, right? We don't care what the address is. Just don't allow that protocol when talking from this group to that group. And that's group-based policy. Really, really cool. The other thing, so that's kind of the different ways of doing the enforcement of the roles in the groups in the network, the different capabilities. The next thing we want to talk about is really doing the containment. And for that, we're going to talk about pxGrid. So when these different devices come into the network, right, we have all the ability to get all this visibility and control their access. And that allows us to obtain this context, which ideally would allow us to get that scalable group and assign the scalable group tag to do our group-based policy, right? Really cool for enforcement. One other thing that we can do with that context is we have the ability to share it out with our other security services over the Cisco Platform Exchange Grid, or pxGrid. The reason why this is interesting is because we can now share this new updated information about the identity and the group and everything with our firewalls, with our secure network analytics, formerly known as StealthWatch, right? So instead of secure network analytics tracking flows only by IP address, it now knows that it's Thomas on his MacBook. And then as Thomas moves around the campus from his desk to a meeting in a conference room, back to his desk, and then maybe goes to a meeting in another building later in the day on, um, we know that that was Thomas, and that was Thomas on his MacBook, and that was Thomas over there at all these different IP addresses that change throughout the day, right? And now Secure Network Analytics is able to quickly tie all these things together and know that it was Thomas at all these different IP addresses throughout the day, so that if you ever have to go back and do an analysis to find out how did Thomas get infected, where was he, when did this infection first come in, Secure Network Analytics has been able to tie all this together because it knew who it was. You don't have to go back and look at your DHCP logs to find out who was that at that particular IP address at that time of day, right? And for doing your secure firewall, you apply the group, and it now knows this source address maps to this tag, and it's able to apply the different ACLs for the firewall policy, and we can kick off vulnerability services, all these great things you can do with pxGrid. So the way this works is we can share this context to these different ecosystem partners, which includes, the other Cisco security appliances and services, or these other ecosystem partners that we have. We can have them supply information to us. So I gave you the example earlier of Cisco Cybervision and the Industrial Network Director helping ISE to understand what types of assets are out there in the network that ISE may not know about because they use very specialized networking protocols, and we wouldn't be able to know. We can't do .1x on them in the manufacturing floor. Now we can know based on the context we get from our partner. We can also do threat mitigation. So if somebody starts misbehaving in the network, we think they're a trusted employee, but they start doing malicious stuff. Maybe they're trying to steal IP and go to another company in a week. We just don't know it yet. Or maybe they've received an infection and now it's the malware that they don't know they have trying to do bad things on the network. If we can detect that with our other security services, we can have them tell ISE to block it. And finally, something we haven't done yet, but the capability is certainly there. When we publish this information via pxGrid, and we have these things called topics, and if we want to share topics between different partners, we certainly have the capability to do that. I'm just not aware of anybody doing that yet today. So let me give you a concrete example of how this works. We have our trusted employee, Jim. We authenticate him. Everything looks fine. We're going to let him in, give him, unfortunately, we gave him full access. And he goes and downloads a nasty payload, right? He gets an email with an infected PDF or a Word attachment or something like that somebody sent him. Fortunately, he's got AMP installed, and it's able to detonate that payload, see the problem, and then notify ISE that we should probably, we've detected a threat, and we should probably quarantine Jim before he opens that payload and starts infecting the rest of the company. So that's one thing we can do there. The other is what we call Threat-Centric NAC. And for this one, we have a lot of vulnerability assessment vendors that we work with as partners. And again, we're going to give Jim full access because he's a trusted employee. And when we do that, we can use pxGrid to let them know, hey, we got a new endpoint that just came in. You should probably go scan it and make sure he's good. When that scan report comes back, they go, oh no, he's got a vulnerability that is a 10, and that's really bad. And then we have a policy in ISE that says if we get a CVSS score greater than 5 from one of these vendors, we need to do a change of authorization and radius and quarantine Jim so that he can get upgraded, patch that vulnerability, and make sure that nobody can infect him from some other computer. So we have a lot of different partners that can help you do these things, whether it's mobile device management or vulnerability assessment, like I said, or a lot of other different things. They have all been verified, and we check it as part of the Cisco Security Technical Alliance Partner Program. So if you have any of these vendors and applications, you can integrate them with ISE. We have lots of guides for you to help you implement them. So check those out. And then another document we have is if you want to know more about those vendor integrations, we have this ecosystem partner integration details doc, which actually tells you what are the protocols they're using and what are the different pxGrid topics they're using to share information. So that's another nice resource for you as well. So finally, I just wanted to share with you, kind of a typical customer journey. I've covered a lot of things today, but you don't have to do them all at once. In fact, we don't recommend you do them all at once. Typically, people start with wireless because you've got to secure that wireless network, right? And inside of wireless, you'll have your corporate access, your different guest portals, and maybe you do some BYOD. And then people start to, want to secure their wired network, get visibility, figure out what they need to secure and what the different policies are. And maybe they even want to understand more about those devices and gather some posture information to see what applications they're running and make sure that they're up to date and not vulnerable. Then, of course, maybe you want to start doing better segmentation. Try out that software-defined segmentation I talked about with scalable group tags. And hopefully, now that you know more about rapid threat containment, you want to maybe do some integrations there. So lots of things you can do with ISE on the enterprise side and the security side. You don't have to do them all at once. In fact, once you do one, maybe you want to go straight from the wired. You want to go straight to doing better segmentation. Or maybe you want to do rapid threat containment. Maybe that's a scenario you're concerned about and you want to utilize that integration with another product. So lots of different options for you. You don't have to do them all at once. And just be aware this is typically how we recommend people do it, is start with one thing, get that working, and then move on to the next capability. So hopefully this has been a good overview of ISE with Zero Trust in the workplace for you. You can catch more of our webinars and capabilities at the ISE Webinar site or on YouTube at ISE-videos. The documents that I talked about, the network device capabilities, the ISE Compatibility Guide, all those are out there for you as well. And so, Rigo, if we have any questions, I'm happy to answer them.
All right. Thank you so much, Thomas. Let me see here what we got. And a big thank you to each and every one of our panelists as well for helping out with the Q&A. Much appreciated there. We do have 2 questions here remaining that we can address before we wrap up.
Yep.
For the first question is, what would you propose if we have a mixed environment, for example, Cisco switches and I believe this is Note HR vendor for wireless?
I don't know what that means, but I'm assuming that it's basically non-Cisco, right? So what do I recommend? What you can do is, like I said, ISE supports any network device that does radius or TACACS. So really what it comes down to is you need to understand what are the hardware and software capabilities of the Cisco devices and that other vendor's network devices. So you may need to read some documentation. First of all, make sure it supports radius. After that, does it do VLANs? Does it do ACLs? Does it do radius change of authorization? These are the things. If you look in the NAD capabilities document, we actually go through and talk about what are these different features in the network device that are required to do things like guest access, right? So guest, typically we need access control lists and we need URL redirection to be able to redirect them to portals for logging in for WebAuth. If you don't have ACLs, if you don't have URL redirection capability, it's kind of hard to do guest. So those are the kinds of things you need to look at. That's not related to ISE. That is 100% on the network device vendor and their capabilities or their particular product. So that's where you got to look and see what they can do. And ISE has built-in profiles to help you with that. So we have them built in for HP, Juniper, other vendors, Aruba, even if you have wireless there. So you can actually choose that profile inside of ISE and should be able to use that right away.
Perfect. Thank you so much. And for the final question here, I don't know if I might need a little bit more context, but the question is, what about different OPs learned in the same port? For example, IP telephony.
Different what's learned in a port?
Different OPs learned in the same port?
OPs. I don't know what OP means in this context. But what they're saying is different things in the same port. So I'm assuming they have multiple endpoints on a single switch port. So typically what you want to do is if you have a phone and another endpoint, which is like a data device, right? The phone goes on a voice VLAN and the endpoint goes on a data VLAN. That's easy to do on a single switch port. This is a topic that we talk about in our ISE Wired Deployment Guide. If you go do an internet search for ISE Wired Deployment Guide, you'll find out how the recommended config for handling that. We also have the ability to do multiple devices on a data VLAN. So you can actually do a computer with a VMware virtual machine, which will actually have a unique MAC address. If it's bridged, you'll get multiple MAC addresses on the data VLAN along with the phone, all on the same port. We can do that as well. The switches, the Cisco switches, have a feature that help you do that called multi-auth. So we can uniquely authenticate each one and then, like I said, apply an access control list. Or we can even apply a scalable group tag per MAC address on the switch port for certain switches and certain versions of software. So those are capabilities we can use to deal with multiple devices on a single port.
Excellent. Thank you so much, Thomas. And it looks, if you don't mind, it looks like we have one additional question that just came up. Can we have IPS and IDS functionality on ISE as well as including AAA?
No, we do not have IDS and IPS. That is not ISE's specialty. ISE is a AAA server. If we were to try and do all that IDS and IPS stuff, that's typically like an inline appliance thing. The scalability, you'd spend a lot of time sniffing packets and looking at things, and that's not what ISE does. It's a AAA server. So our job is to do network access control policy. We authenticate users and devices. We'll do web portals and different things, posture, redirections, all these different things. But when it comes to sniffing packets and packet inspection, that kind of stuff, we leave that to other security services. So you'll want to use other firewalls or other things to do that for you.